So in this short video of comparing the chi-squared tests, we are going to take a look at the main differences, which is going to be talking about the type of test that we actually use on our calculator, but also the subtle differences in the null versus alternative hypothesis. Now, our first series of videos on chi-squared talked about the goodness of fit test, and there were two different types of goodness of fit tests. Those were preference, no preference, and those that actually talked about a population fitting the distribution or populations that did not fit the given distribution. So an easy way to figure out which one is which in the goodness of fit test is that the goodness of fit test with preferences, if you see the word preference, that is a dead giveaway. Also, other words that would kind of give you a clue, like the same, like the choices of colors are the same, or there's no strong leaning of one versus the other. Whereas population, to check to see if the populations fit a given distribution, is pretty much always going to have percent signs by them. So the goodness of fit test obviously uses on the calculator the chi-squared GOF. And if you don't have that on your calculator, you can watch those videos on how to do it using the second VAR's chi-squared CDF function. Now, what you just probably finished doing today was the test of independence and the test for homogeneity. Well, this just uses the chi-squared test on the calculator. And the format is pretty standard here, where in the test of independence, you have where the column category is independent of the row category, and the alternative would be the column category is dependent on the row category. Most of the time, your rows will not necessarily be 2. You may have more than 2 rows, but for the test for homogeneity, your row number has to be equal to 2. If it's not equal to 2, you can't really test the two groups there. So the test for homogeneity has this very simple, at least in this book and in these lessons, the test for homogeneity is going to have these kind of simple restrictions on it. But that's it. That you will probably need to back up to the video to copy down the null and alternative for each of these here. And again, I decided to type them out instead of having you write them down. You can see in brackets I put column category, which is where you're going to fill in your rest of your null and alternative hypothesis, whereas in the test of independence you do have row and column categories pretty much given here. But that's really all there is to say about this final section of our time together talking about chi-squared. It's really just being able to tell which one is which when you need to use it. Well, thank you for watching and getting through chi-squared distribution with me, and I appreciate your hard work and effort doing the mathematics and statistics.